Basic definitions and sampling methods. Statistics is the study of how to collect, organize, analyze, and interpret numerical information from data. We're going to learn all these four things later in the sections. For today's, in this video, we're going to focus on how to collect data. Before we look at how to collect the data, let's look at basic definitions. Population describes all of the objects or people whom you want to draw conclusions. So population is what we want to study. And sample is subset of the entire population of interest. So oftentimes population is large, so we cannot obtain entire population. For example, if we want to study some aspects of people in the United States, we cannot survey every single individual in the United States. Therefore, we're going to select sample to represent that population. As you can see in this picture, here's a target population which we as a human or researchers define, and we select sample, and from sample we draw a conclusion of our population. And we'll look at that how to draw a conclusion in the process later in the sections. But for today, again, like I said, we're going to focus on how to select those samples, because the way we select sample is important. So let's look at example here. We might be interested in the average weight of deer as a species. Then all the deer are the population. But as you can imagine, it is not possible to collect every single deer's weight in this world. So we gather data on instead of gathering data on entire population, we might gather 100 deer in the area to find the average weight. In this case, this 100 deer is a sample. Now the question is how we select sample from population. That's where sampling methods comes in. So sampling methods are there so we can collect sample from population with most unbiased way possible. Okay, so the way we select sample from population, when we do that, we want to remove bias as much as possible. So let's look at all the sampling methods. The first method is called simple random sampling. In simple random sampling, each sample of the same size has an equal chance of being selected. So let's look at an example. There are 200 employees in a certain company. The human resource department wants to draw a simple random sample of 30 employees to fill out a questionnaire about their attitude towards their jobs. So here we want to select 30 random employees out of total 200. So how do we do that? Well, one way is using a technology or a computer or a calculator, and we assign number to each employee. So unique number to 1, 2, 3, 4, 5, all the way to 199, 200. So each employee has their own unique number. And from this 200, we randomly select 30 numbers. 30 numbers. We can also do this by, if we don't have a computer or any technology, we can put 200 pieces of papers with each number written in it, and we select 30 numbers randomly. So the important thing in simple random sampling is that each individual or an object has an equal chance of being selected. So it's the most basic way of sampling. Stratify sampling. In this sampling method, we divide the entire population into distinct subgroups called strata. All members of stratum share specific characteristics. And then random samples are drawn from each stratum. So let's look at an example. A high school has 100 freshmen, 120 sophomores, 90 juniors, and 105 seniors. So within an entire population of high school, the high school is divided into distinct subgroups. In this case, we call strata. So freshmen, sophomore, juniors, and seniors, each of those classification is a strata. So we have 4 strata, or 4 stratum in this case. The cafeteria wants to draw a sample of 90 students to ask their opinion of new lunch menu. They draw a random sampling of 20 freshmen, 30 sophomores, 18 juniors, and 22 seniors. So what's happening here is that from each strata or each subgroup, we select randomly 20 freshmen, 30 sophomores, 18 juniors, and 22 seniors from each group. So in Stratify sampling, each subgroups get representation in sampling. Because if we did not use a Stratify sampling, it is possible that 90 people, 90 students they select, or all might come from just sophomores, or maybe sophomores and freshmen only. In that case, juniors and seniors do not get to voice their opinions. So Stratify sampling ensures that each subgroup gets representation in sampling. Systematic sampling. From a random starting point, every kth member of population is selected. So let's look at an example. Police officer at a sobriety checkpoint pull over every 5th car to determine if the driver is sober. So police officer, he or she has to start a random starting point. That's the important thing about systematic sampling. And then from that random starting point, he or she selects every 5th car. So it's a systematic sampling. Cluster sampling. In cluster sampling, divides population into clusters called groups, and then randomly select some of the clusters, some of the groups. And all the members from selected cluster are in the cluster sample. So let's look at an example. Officials at a Metropolitan Transit Authority want to get an input from people who use a certain bus route about a possible change in the schedule. They randomly select 5 buses during a certain week and poll all riders on those buses about the change. So in this example, the population is all the buses. So we can think as each bus as a group or a cluster. And from each group, each cluster, there are many buses, but we randomly select 5 buses only. And from all those passengers in the 5 buses are selected as sample. So both cluster and Stratify use sampling, but we should not get confused in those two, sampling. So let me explain the difference between these two, because both of the sampling methods are involved with groups. So in Stratify sampling, in population, we divide population into certain groups. So let me maybe do it this way. There are 1, 2, 3, 4, 5 groups. And in Stratify sampling, from each group, we randomly select certain number of people or some number of objects. So each of them, maybe we select 4 in here, 5, 3, another 3, and maybe 4. So from each subgroup, we get simple random sampling. So each group gets represented. In cluster sampling, we also divide into groups, but we randomly select a certain number of groups. So let's say maybe we only select 2 groups. So we randomly select this one and maybe this one. And all the individuals from these 2 groups are selected. So another example of cluster sampling, we can think as there's 50 states in the United States. We can randomly select 17 states. And all the people in the 17 states are maybe selected for sample, something like that, where we only select group as randomly, and all the individual objects are in that group is selected for sampling. Convenience sampling. Convenience sampling is often actually produce bias. But then why are we looking at this? It's because we want to recognize when we see convenience sampling so that we can be more cautious when we read the results from convenience sampling. So convenience sampling is using results that are readily available. For example, all the customers who enter a store at a particular time were given survey to fill out concerning their opinions of service at the store. So this is convenience sampling because the person who took the survey only surveyed a customer who entered the store at that particular time. So we need to be cautious. I mean, we cannot always uh, obtain sampling in the method we would like. So one could argue that having convenience sampling is better than not having any, but we always need to be careful when we read the result from convenience sampling because it could be very biased. Another biased sampling is also voluntary response sampling, using results that are voluntary. For example, a radio host receives a phone calls from listeners to voice their opinion on a new federal tax policy. So the fact that listeners volunteer to call and voice their opinion, the sampling is biased. So again, it's not that we necessarily want to use this method when we do research. It is more important for us to recognize when these are used when we look at a result or conclusion from a study. Again, similar to the convenience sampling, one could argue that having a sampling through a voluntary response is better than not having any. But again, the whole point of knowing these two potential bias sampling so that we can recognize when they're used. So let's look at more definitions. A statistic. So this course is statistics without an S. A statistic is a number that describes sample. And we'll look at more examples of statistic as we go in later sections. But for now, note that when we say a statistic is a number that describes sample. So you can remember easily with S, statistic, sample. Parameter is a number that describes the entire population. So you can also remember with P, parameter, P, population. So let's look at an example. 97% of carpenters in Florida are male. So in this example, carpenters in Florida is population. Therefore, the 97%, which is a proportion, this proportion is a parameter, example of a parameter. In B, in a sample of 100 survey patients who were given a new pain reliever, 78% of them reported significant pain relief. So in this case, this is sample, a sample of 100. Therefore, the 78%, the proportion, is an example of a statistic. For a statistic and parameter, it will become more important later on. We just want to introduce ideas early because it's important for us to always distinguish if the data or numerical value we're looking at is from a population or a sample. For example, proportion from population, proportion from sample must be distinguished.